150 milliseconds.
It's a number that's really hard to wrap your head around.
It really is. I was trying to visualize it before we started. A human blink is, what, 300, maybe 400 milliseconds?
Yeah, about that.
So we're talking about something happening literally twice as fast as you can blink your eye.
It's faster than your brain can even process a signal. If you touch something hot, that signal from your finger to your brain, that takes longer than 150 milliseconds.
And that's the goal. We're not talking about a race car. We're talking about a blockchain. We're talking about Solana.
And look, Solana has always been fast. I mean, that was its whole pitch from day one. But this is different. This isn't just a small upgrade. It's a fundamental rewrite of the network's DNA.
Welcome back to the deep dive. Today, we are getting into Alpenglow. It is this massive consensus overhaul that, well, it's rolling out right now in early 2026. We've got the Anza white papers, we've got some great technical analysis from Helios and Figment, and some, let's just say, some very aggressive market projections from late last year that we have to talk about.
It's such a critical moment because there's this real tension in crypto, right? You have Ethereum, which is all in on the modular path.
Right, layer 2s for everything.
Exactly. The base layer is for security, and everything else happens somewhere else. But Solana is, it's betting the house on the opposite idea, that a single monolithic layer can actually be fast enough for global finance.
And that's our mission for this deep dive. Can a decentralized network really compete with the speed of, say, the NASDAQ? We're going to unpack the tech, which means saying goodbye to some old friends like proof of history.
A big one.
We'll look at what some are calling the upgrade nobody is talking about, which is all about validator economics. And yes, we'll get to the price. People are throwing around numbers like SOL hitting $500, so we need to figure out if that's real or if it's just hype.
But you can't understand the price case until you understand the engine. Because getting to 150 milliseconds, you have to break some things to move that fast.
Let's start with the breaking them. Segment 1, the tech overhaul. The first thing that really jumped out at me from the Anza papers was proof of history. It's gone.
It's the end of an era, really.
But POH was the brand. That was the secret sauce. I mean, Solana, the blockchain with a clock.
Yeah.
Why would they ditch their most famous feature?
To get that, you have to remember what POH actually did. It was, for its time, a brilliant hack. Getting thousands of computers to agree on what time it is, that was the big problem. So POH was like a global clock.
A metronome everyone could trust.
A cryptographic metronome, exactly.
Yeah.
But the problem, and the Helios reports really highlight this, is that running that metronome is incredibly heavy. It chews up CPU. And ironically, the feature built for speed eventually became the bottleneck.
Just got too heavy to carry.
It introduced latency and these very specific vulnerabilities like hash stalling. If the leader even hesitated for a second, the whole network could just stutter. So Anza, the team that spun out from Solana Labs, they looked at this and just said, look, if we want 150 milliseconds, the metronome has to go.
So if you kill the global clock, what stops it from being total chaos? How do they all stay in sync?
They're moving to a system that is, it's shockingly simple. It's just fixed 400 millisecond block times.
That's it.
And strict local timeouts. Instead of complex cryptography to prove time passed, they're basically just trusting that modern computers have good clocks.
So it's less cryptographic proof and more if you're late, you're out.
Pretty much. A leader misses their 400-meter slot. Boom, timeout. Next one up.
Okay, so that clears the runway. But the real speed that comes from these two new things, Votor and Rotor, I love the names. Let's start with Votor, because the stats here are just wild.
Votor is the new voting engine. And for any developers listening, this is probably the most critical change. You have to realize how incredibly inefficient the old Solana system was.
How bad are we talking?
Okay, so before Alpenglow, every single time a validator voted on a block, that vote was an on-chain transaction. It took up space. It cost a fee.
I read somewhere that something like 3/4 of all the traffic on Solana was just validators voting.
That's right. Imagine a meeting where 75% of the talking is just people shouting, yep, I heard that, over and over. It's noise. It makes it impossible for actual conversations, or in this case, user transactions, to get through.
So Votor takes all that voting off-chain, but what does that actually mean? Is it just happening on some server somewhere?
No, and that's the key. It's still decentralized. It's just not on the main ledger. Instead of every validator writing their vote to the blockchain forever, they send these little vote messages directly to each other.
So they're whispering in the hallway instead of shouting in the main room.
That's a great analogy. And then this is the really cool part. They use something called BLS, signature aggregation.
That sounds very technical.
It is,
Yeah.
but the idea is simple. The old way was like everyone mailing a separate I agree letter to a central office. Thousands of letters. BLS is like passing around a single sheet of paper.
And everyone just signs the one sheet.
Everyone signs the same sheet. So the network only has to check one mega signature to know thousands of people agree.
That has to be so much more efficient.
It's efficient enough to create two different speeds for the network. There's the fast path. If 80% of the stake signs that sheet instantly, the block is finalized, done. That happens in about 100 milliseconds.
100 milliseconds, wow.
But, things go wrong. A transatlantic cable gets choppy, nodes go offline. If they don't hit that 80% right away, it falls back to the slow path.
And what's slow in this new world?
Somewhere around 200, maybe 250 milliseconds.
Okay, so the failure mode is still faster than a human can react.
Exactly. The slow path just needs 60% agreement, but it takes an extra round of messages. It's a safety net. It ensures the chain never stops, even if it's struggling.
Okay, so Votor is the agreement. Then we've got Rotor, the delivery system.
Right. Rotor replaces the old system, Turbine. And Turbine was basically a game of telephone you played as a kid. The leader tells validator A, who tells validator B.
And by the end, the message is completely garbled.
Things got messy. Packet loss was a nightmare. One node in the middle hiccups, and everyone downstream gets nothing. Rotor is a single-hop direct relay system.
No more telephone tree.
No more tree. The leader just blasts the data out to key relays, and they use something called erasure coding.
That's like from hard drive rates, right, for data recovery?
Same idea. The block is broken into pieces with redundant data built in. You only need to cache 60% of the pieces to rebuild the whole thing. So even on a choppy connection, the block gets through intact.
So Votor clears the pipes, Rotor is the fire hose.
And that's how you get to a target of 150 meters deterministic finality.
Which leads right into the so what? Because I can just hear the Ethereum crowd saying, who cares? My layer 2 feels instant. Why does this actually matter?
It matters because of what the word finality means. On Ethereum's mainnet, real finality, the point where a transaction is totally irreversible, is about 12 to 15 minutes.
Minutes, not milliseconds.
Minutes. And yeah, on layer 2s, you get a soft confirmation that feels fast. But for optimistic rollups, the actual hard finality can be days.
So for buying a coffee, soft confirmation is probably fine.
Of course. But if you're trying to run the NASDAQ, no way, you can't have soft settlement. And this is the whole decentralized NASDAQ idea that firms like Figment are all about.
This is the CLO instrument, the central limit order book.
Exactly. For years, DeFi has been stuck with AMMs, automated market makers, liquidity pools. We used them because real order books were just too slow for the blockchain.
Because by the time you post your bid, the price has already moved and you get wrecked.
You get front run, you get picked off. That's the optimistic gap.
Yeah.
You're just waiting, hoping your trade went through. At 150 meters finality, that gap is gone. It just disappears.
So a market maker on a Solana DX can update their quotes just as fast as they can on Binance.
For Coinbase or the New York Stock Exchange, it kills latency arbitrage. It means you can build a decentralized exchange that performs exactly like a centralized one.
That's a huge deal. That completely blurs the line between Web 2 and Web 3.
And it's not just finance. Think about gaming. I mean, real-time gaming. Your reaction time is about 250 milliseconds.
Yeah.
If the chain state updates faster than you can think, you can put an entire first-person shooter on-chain.
No more turn-based card games.
Real time. That was just physically impossible before Alpenglow.
Okay, so the tech is a game changer. But let's pivot to the money, because buried in all this is a detail about validator economics that I think most people just scrolled past. And this might be the most bullish part of the whole thing.
The cost savings.
Yeah,
you're right. This is the upgrade nobody's talking about, and it fundamentally changes the health of the entire network.
Let's do the numbers. In the old system, validators paid transaction fees on every single vote.
Yep. The Helios report put that at around 1 SOL per day. Per validator.
Which at today's prices is, what, $60,000 a year?
Around 60 grand a year. Just burned. Gone. Just to do your job and participate in consensus. That is a massive barrier to entry.
It means you have to be really well funded to even play.
Right. But with Alpenglow, voting is off-chain, so...
that cost goes to zero.
Effectively zero. No more gas fees for voting.
So if I'm a validator, my single biggest operating cost just vanished.
It completely changes the math. Before, you needed about 4,850 SOL staked with you just to break even on costs. After this, the break-even point is around 450 SOL.
Wow. From almost 5,000 down to 450.
It's a tenfold drop. It democratizes the whole thing. It means a small dev shop, a university, a hobbyist can actually run a profitable node. And that's a direct answer to the biggest criticism Solana has always had, that it's too centralized.
But I have to be the skeptic here. There's no free lunch. We're getting crazy speeds, lower costs. What's the trade-off? I saw this 20+20 security model mentioned. That sounds weaker than the standard.
And that is the controversial part. You're right to flag it.
Right.
Traditional Byzantine fault tolerance works on a 33% threshold. As long as less than a third of the network is malicious, you're safe.
That's the gold standard.
Alpenglow changes the equation. It's designed to tolerate 20% malicious stake, plus an additional 20% of the stake just being offline.
Why make a separate category for offline?
Because the researchers realized that in the real world, nodes crashing or having a bad connection is way, way more common than nodes actively trying to attack the network. They optimized for liveness.
But they did lower the malicious threshold from 33 to 20%. Doesn't that make it easier to attack?
Technically, yes, it lowers the capital required for an active malicious attack, but it raises the network's tolerance for just real-world messiness. It's a pragmatic trade-off. They're betting the risk of a coordinated multi-billion-dollar 20% attack is lower than the risk of 20% of validators just going offline by accident.
And given Solana's history with halts, I can see why they'd prioritize that.
Exactly. They are scarred by those halts. Alpenglow is designed to make sure the network's heart never stops beating.
Let's zoom out. What does this all mean for someone's portfolio? The investment case. It's January 2026. The upgrade is happening. The sources we have are throwing out some huge numbers for SOL.
The sentiment is incredibly bullish.
Yeah.
I mean, you have to remember, the validator vote for this back in late 2025 was 99%. Yes.
You can't get 99% of people to agree on anything.
That vote alone pushed SOL up to around $210. But the projections for after this mainnet launch is complete. They're in the range of $400, some even going over $700.
And the thesis there is what? Just fast chain, price go up?
It's the high beta thesis. The idea that when blockchain really goes mainstream for things like payments, the value will flow to the path of least resistance.
The fastest and cheapest pipe.
Precisely. The sources talk about a Western Union pilot program that is only possible because of this sub-second finality. If Solana can capture high-frequency trading and global payments, the demand for SOL, for staking, and for bandwidth just, bang,
Yeah.
it explodes.
So even with no vote fees, the demand for the token itself just goes way up.
Right, and if you're pulling volume away from centralized exchanges and TradFi, the value accrual is enormous. The Ethereum killer thing stops being a meme and starts being a real structural threat. Why would you use a slow, expensive, fragmented system if there's an alternative that feels just like Web 2?
The monolithic bet pays off.
That's the bet. One giant, global, super-fast computer. Alpenglow is the engine that finally lets that computer run at the speed of light.
Okay, it sounds almost too good to be true. Which brings us to risks and realities. Where could this all go wrong? Physics.
The speed of light is a hard limit. For data to be finalized in 150 milliseconds, it cannot physically travel around the world multiple times. It just can't.
So if the network needs that kind of speed,
It creates a huge incentive for geographic centralization. If you're a validator in Australia, most of the stake is in data centers in the US and Europe, you're too far away. You'll be too slow. You'll miss the votes.
so the network naturally starts to cluster in places like Ashburn, Virginia, or Frankfurt.
Exactly. So you might get decentralization of ownership. More people can run nodes. But you get centralization of location. And that's a big philosophical compromise.
That's a huge one. What else?
There's the spam risk.
Mm-hmm.
We said voting is off-chain and free now.
Right.
Well, if it's free, what's stopping someone from just flooding those side channels with garbage data? A new kind of denial-of-service attack aimed right at the consensus layer. The papers talk about mitigations, but we won't know until it's battle-tested.
And the software itself. Firedancer was supposed to be the big second client.
It's a bit of a single-client risk right now. The network is still overwhelmingly dependent on the Agave client, the one Anza maintains. Firedancer's coming, but Alpenglow just raised the bar. Now they have to implement all of this too.
So if there's a critical bug in Agave,
The whole network is vulnerable, yes. Client diversity is still a future goal, not a current reality. And that's a single point of failure.
and this is all happening now, this quarter. This is a massive coordinated upgrade.
Is a hard fork level of coordination. If they mess up the rollout, the chain halts. And a halt today with billions locked up is a much bigger disaster than a halt was in 2022.
High risk, high reward.
That's always been the Solana story.
So to wrap this up, we've gone from the death of proof of history to the birth of this 150 millisecond blockchain.
It's a complete architectural shift. They're trading a little bit of theoretical security for a massive gain in real-world performance that rivals Web 2.
Which brings me to this final thought. We've spent years arguing about decentralization versus scale. But if this works, if I can use a Solana app and it settles instantly, just like my bank app, but I'm the one holding my keys.
Then the line between the two just blurs completely.
Exactly. If the end user can't tell the difference speed-wise between Solana and a centralized database, but they keep full self-custody, has crypto finally won? Or did we just reinvent a faster, more complicated cloud server?
That's the question for 2026.
We'll be watching the mainnet deployment very closely. If you're a developer, get your nodes updated. If you're an investor, well, buckle up. This has been The Deep Dive. Thanks for listening.